Way 66 deals with being able to calculate moles. And for this, you're going to need table T's equation. To get the number of moles of a substance, you're going to take its given mass and divide it by gram formula mass. Now, you already know how to calculate gram formula mass. We sum up all the masses of all the atoms present within a compound. So, for example, if you're looking at a compound like ammonia, NH3, we would calculate its gram formula mass by adding up the mass of that one nitrogen plus 3 hydrogens to get its gram formula mass. Now, you're going to need to use the atomic masses present on the periodic table, and you can easily round those numbers to the nearest whole number in order to calculate that. Now, quite frequently, many of these problems, they give you the gram formula mass in the question. So you can just use that to calculate the number of moles. If not, you'll have to calculate it yourself. So let's try some problems. What is the number of moles of potassium fluoride in a 29-gram sample of the compound? So in this problem, think about what you're given and what you need. Here you're given the mass of the substance, and you need to calculate moles. In order to use the formula provided on table T, we're going to need to use the gram formula mass of potassium fluoride, and you should know how to calculate that. Notice that the compound contains 1 atom of potassium and 1 atom of fluorine. To get the gram formula mass, we take its mass on the periodic table, multiply it by the number of atoms, which in this case is just 1. So 39 grams of potassium, 19 grams from the fluorine will give you a total gram formula mass of 58 grams. To get the number of moles, moles is equal to the given mass, 29, divided by the gram formula mass. So 29 divided by 58 will give you 0.5 moles of potassium fluoride. So the answer is 3. Next question. A sample of calcium carbonate has a mass of 42.2 grams. This is the given mass. Calcium carbonate has a gram formula mass of 100 grams per mole. It gives it to you. So you need not calculate it by summing all the masses of each atom present in the compound. Show a numerical setup, meaning show your work, for calculating the number of moles in a sample of calcium carbonate. Notice this problem asks you to show a numerical setup. So do not go through the effort of trying to solve the problem. Simply just show your work, how you would use this information to calculate the number of moles in a sample of calcium carbonate. Using the formula, you know that moles equals the mass, the given mass, divided by the gram formula mass. So you just have to divide two numbers, 42.2 grams divided by the gram formula mass of calcium carbonate, which is 100 grams per mole, and this will calculate the number of moles present in 42.2 grams. Alternatively, you could use dimensional analysis. This is a technique that involves cancellation of units. Here we know that 42.2 grams times 100 grams per 1 mole of calcium carbonate will cause the grams to cancel, and this will give you the number of moles. Alternatively, you could set up a proportion. You know that X over 42 is equivalent to 1 mole over 100 grams. Cross multiply, and that will solve the answer for you. Next problem, what is the mass of 1.5 moles of carbon dioxide? Notice that for this problem, it starts off with the number of moles, and it wants to know the mass, the given mass. So you're going to need to rely on the gram formula mass of carbon dioxide. If you don't already know, carbon's mass is 12, oxygen's mass is 16. To get the gram formula mass, we take 12 plus 2 times 16, which is 32, and that gives us 44 grams of carbon dioxide. So if this is what our formula is, we have 1.5 moles of carbon dioxide equal to X, some unknown mass of carbon dioxide, divided by 44. How do we solve this? Well, we multiply by 44 to both sides, and the amount of grams of CO2 is equal to 44 times 1.5, which will give you 66 grams. I'm sorry, yes, 66 grams. So the correct answer is actually choice 1, not choice 2. My apologies. Okay, so when it comes to calculating moles, note that the formula is given to you in the back of reference table T. In either case, they'll either provide you with a given mass and ask you to calculate moles, or they'll provide you with the moles and ask you to calculate the given mass. Either way, you're going to have to rely on the gram formula mass. Sometimes this will be given to you. Sometimes you'll have to calculate it for yourself. In either case, once you have these two bits of information, you can go between mass and moles using this formula. Hopefully this was helpful, and thank you for watching.